Hello everyone, welcome to another video tutorial on inverse variation. What is an inverse variation? As one variable increases, the other one decreases and vice versa. Unlike direct variation, which we have discussed on our last lesson, inverse variation is when one quantity increases, the other decreases, or its opposite. As well as vice versa, when one decreases, the other one will increase. So the expressions or clue words that denotes inverse variation are the following. We have y varies inversely as x, given that we have two variables y and x. We also have y is inversely proportional to x. And then for the representation, we will have y equals k over x, denoting that y is inverse with x. And then for the equation of the variation, it's just the same, y equals k over x, wherein k is the constant and it should not be equal to 0. For the translation, we still have to translate statements, table of values, and graphs. Let's begin with the statements. So we have here p varies inversely as z. So this will be written as p equals k over z. Next example, atmospheric pressure A varies inversely with the altitude h. This will be A equals k over h. And then for our third example, we have the time t required travel a given fixed distance is inversely proportional to the speed r. So we have t equals k over r. Although we have here another variable or another quantity which is the distance, it is denoted here in our statement that it is fixed. Therefore, the distance here is the constant of this problem or statement. Let's move forward with the table of values. Starting with the first one, we have here x and y values. For the x values, we have 2, 3, 4, 5, and 6. If we are going to analyze its order, this one is increasing in order. And then when we look on the values of y, we have 60, 40, 30, 24, and 20. So as you can see, this one is decreasing in order. Again, when we say inverse variation, when one quantity increases, the other one decreases. So this might be an inverse variation. But for us to verify or be sure that this is an inverse variation, we must find the constant product. In finding the constant product, we just multiply the first set of x and y. So that is 2 times 60, 120. 3 times 40 will also give us 120, as well as 4 times 30, 120. 5 times 24 and 6 times 20 will also give us 120. So that is what we call the constant product. If we have the constant product, therefore this is an inverse variation. Or we are sure that this is an inverse variation. Now we move forward with the equation of the variation. So for the equation of the variation, since we have an inverse variation, this will be y equals k over x. And now we find or we get values from the table. So we have x sub 1 which is 2, and then we have y sub 1 which is 60. Now that we have x and y value, so we substitute in our formula. So this will be 60 equals k, which we have to obtain, and then 2 is the value of x. So you can apply multiplication property of equation wherein you multiply 2 to both sides of the equation for you to cancel out the denominator, which is 2. So canceling this out, we will have k, and then 2 times 60, that will be 120. So another method on how you are going to solve that equation. So I will just be copying it again. 60 equals k over 2. You can simply apply cross multiplication. 2 times 60, it's 120, and then the remaining on the right side is k. So as you can see, we have the same answer. And another technique, if you have here the constant product, it is also equal to the constant of an inverse variation. Therefore, you can already write the equation of the variation even if you're not solving the problem or you're not getting some values from the problem. Only using this constant product or just multiplying, you will obtain the constant. So now that we have the constant, this will be y equals 120 over x. So this is our final answer or the equation of the variation. Next, we have here the number of persons and then we have here time to finish the job in minutes. So the number of persons are the values of x and then the values of y is the time. So for the number of persons, we have 1, 2, and 10. Obviously, it's increasing in order. And then for the time, we have 40, 20, and 4. So that's decreasing in order. So this is an example of real-life situation involving inverse variation. As the number of person increases, definitely the time to finish the job in minutes will decrease. So if there's only one person working, he or she will finish the job on 40 minutes. If they are two, it will decrease. It will only be 20 minutes. Or if 10 persons work on the same project or on the same work, the time to finish the job will be less. So on this problem, it's only 4 minutes if they are 10 persons. So now we find the constant product. Okay, constant product. I will just erase additional t. So this is constant product. So just multiply 1 times 40, it's 40, 2 times 20 is also 40, as well as 10 times 4, it's also 40. Therefore, this is an inverse variation. And then, after knowing that it's an inverse variation, we find the equation of the variation. Again, for the technique of the equation of the variation for inverse, we just copy the constant product as our value of the constant. So knowing that it's x and y, so the translation is y equals k over x. And then the value of k, which is 40, this will be y equals 40 over x. So no need to solve because we are going also to arrive on this answer, which is 40. Last example for the table of values, we have the speed in meters and time in seconds. We have 5, 2, 3, and 4. So as you can see, this one is inconsistent, not increasing, not decreasing. As well as on the time, we have 10, 4, 6, 8. 10 to 4, it decreased. 4 to 6, it increased. And then 6 to 8, it increased again. So as you can see, inconsistent. So this one is not an inverse variation, not even a direct variation. So we are done with our table of values. We proceed with the graphs. So the graph of an inverse variation is usually like this one. We have here the curved line that denotes y equals k over x. For our example, we have here this table wherein we have t as the values of x because it's on the x-axis. So that's the time. And then for the values of y, we have r. So r is the speed. So as you can see, we have here miles per hour in speed. So let's list down beginning with on the left side or the point on the left side. So we have 2 hours, 120 miles per hour. If it's 3 hours, 80 miles per hour, 4 is 60, and then 5 is 48. So for the values on the t or the time, it's increasing. And then for the values of r or the speed, it's decreasing. So definitely this might be an inverse variation, since we have here a curved line. That is the usual graph for inverse variation. So for this one, in reality or in real life application, so as the time or as the speed increases or decreases, therefore the time for arrival also will decrease. So for example, we have here 120 miles per hour. You will arrive earlier or you will only take 2 hours to arrive on your destination. Unlike if you are going to have 80 miles per hour, this will lengthen your travel, so that will be 3 hours. So that's why we have increasing in the number of hours and decreasing in our speed. So as your speed decreases, therefore your time will increase. So that's the real life application. For the constant product, it's obviously 2 times 120. So this one is the constant product. 2 times 120, that's 240. As well as 3 times 80, 240. 4 times 60, it's also 240. And the last one will also give us 240. Now that we know that it's the constant product, we find the equation of the variation, because this one is identified as inverse variation. For the equation of the variation, since we used R and T, so R will represent or replace Y, so this will be R equals and then K on the numerator, and then on the denominator we have the value of X that will be replaced by T. And then our constant, which is 240, so this will be equal to R equals 240 over T. So this is our translation or our final answer for the equation of the variation. Now we move forward with our last topic for inverse variation, which is on solving for the variables. Example number 1, the volume V of gas at constant temperature varies inversely as the pressure P. If V equals 5 and P equals 9, find the equation of the variation in K. So since this is an inverse variation, because we have here inversely or varies inversely, we translate. So this will be V equals K over P. We write down the given values. V equals 5. So let's write this down correctly. So we have the value of V equals 5, P equals 9, and then K is missing as well as the equation of the variation. Substituting the given values, we will have 5 equals K over 9. Again, we can apply cross multiplication or multiplication property of equality. So I just cross multiply 9 times 5, which is 45, and then the remaining variable on the right side is K. So 9 times 5, 45. So K is equal to 45. Now that we have the value of K, we substitute for the equation of the variation. So this will be V equals 45 over P. Next example, the altitude H of a triangle varies inversely as its base B with a constant area. If H equals 7 and K equals 77, find B. So H is equal to K over B, given that the altitude varies inversely as the base. The given values, H equals 7, K equals 77, and now we are looking for the value of B. Substitute in our translated formula, so this will be 7 equals 77 all over B. Cross multiply, 7 times B, it's 7B equals 77. Divide both sides by the number beside B, which is 7. 77 divided by 7, we will have 11. So the value of B equals 11. Third example. The temperature at which water boils varies inversely as the number of feet H above sea level. Find T when H equals 13 and K equals 156. So we have the temperature and then the number of feet above sea level. So this will be T equals K over H. Given values, let's list down. H equals 13, K equals 156, and then we are looking for the value of T, or the temperature. Substitute the given values. This will be T equals 156 over 13. Dividing 156 divided by 13, that will give us 12. So the temperature is 12. Let's proceed with example number 4. So if y varies inversely as x and y equals 48 when x equals 10, find y when x equals 32. So we have two sets of x and y's. Again, translate first, y varies inversely as x, so this will be y equals k over x. Values, we have y sub 1 equals 48, and then we have x sub 1, which is 10. K is missing, y sub 1 is also missing, and then x sub 2 is equal to 32. Let us find the value of k first using our first set of values. So this will be y sub 1 equals k over x sub 1. 48 is equal to k over 10. Cross multiply, k is now equal to 480. Now that we have the value of k, we find what is the value of y sub 2, which is k over x sub 2. So for y sub 2, just copy the obtained value of k, which is 480, and then the given x sub 2, which is 32. 480 divided by 32, the answer is 15. Therefore, the value of y sub 2 is 15. So now we are done with our last example. So if m varies inversely as n, and m equals 3 over 14 when n equals 24 over 5, find m when n equals 13 over 5. So as you can see, we have here fractions as given. Translate m varies inversely as n, so that will be m equals k over n. List down all the given values. First value of m is m sub 1, that's 3 over 14 based on what is given on the problem. N sub 1 is equal to 24 over 5. And then we are looking for the value of k. And then for m sub 2, that is asked in the problem, and n sub 2 is equal to 13 over 5. Let's solve for k using the first set of given values. So this will be m sub 1 equals k over n sub 1. 3 over 14 is equal to k over n sub 1, which is 24 over 5. Again, just cross multiply. 3 over 14 multiplied to 24 over 5. So after that, we simply multiply. So 3 times 24. So that's 72. And then 14 times 5, it's 70. So the value of k is 72 over 70. But 72 over 70 can still be reduced as 36 over 35. So this is the lowest term. So definitely the value of the constant is 36 over 35. Now we find the value of m sub 2. So m sub 2 equals k over n sub 2. M sub 2 is equal to the obtained value of k, 36 over 35 divided by 13 over 5. Now that we have to divide these two fractions, we get the reciprocal of the denominator. So reciprocal of 13 over 5 is 5 over 13. After that, we multiply. So 36 over 35 multiplied to 5 over 13 equals m sub 2. We can still simplify this. So 35 and 5 can both be divided by 5 for this to be simplified. 5 divided by 5 is 1, and then 35 divided by 5 will be 7. So for the new numerator of this one, we have 1, and then for the new denominator, we have 7. 36 times 1, we will have 36. While on the denominator, we have 7 times 13, which is 91. So we have 36 over 91, which cannot be reduced in its lowest term, so this will be the lowest term, 36 over 91. So that will be the value of n sub 2. So that's all for our discussion of inverse variation. Hope you learned something today. Thank you for listening. God bless everyone.